All right, so let's see this particular question, parenthesis checker. So in this particular question, we are given an input string like this, right? And this input string will only have either opening brackets or closing brackets of different types, right? It could have curly bracket, it could have square bracket, or it could have circular brackets, right? What we need to do is we need to see that whether this particular input expression is balanced or not. The braces in this particular input expression are balanced or not, right? That's what we need to check. And these are the rules that we have to follow. So open brackets must be closed by the same type, right? And open brackets must be closed in the correct order, right? So for example, over here, if you see, we have one curly bracket, opening curly bracket, one opening square bracket, and one opening circular bracket, right? And in the same order, we also have the closing brackets of each type, right? And we have to also see whether the brackets are closed in the correct order or not. For example, over here, if you see, the last open bracket is a circular open bracket, right? So we have to see that the very next closing bracket that we are getting should be a circular closing bracket only, right? Because the bracket that is open last should be closed first, right? That's the rule that we have to follow, and that's the order that we have to maintain. If there would have been a closing square bracket right after this opening circular bracket, then it wouldn't have been balanced. It wouldn't have been valid, and we would have returned false in that case, right? So that's what we need to check over here, whether this particular given expression of brackets is balanced or not, right? If it is balanced, we will just return true. If it is not, we will return false, right? So that's the entire question. Now maybe you can just pause this video and try to think of a solution. And once you're done, you can just come back and check the solution. Okay, so now to solve this particular question, see, we will make use of the stack data structure over here, right? So what we will do is we will traverse each element of this particular input string, right? The input expression. And what we will do is whenever we are finding an opening bracket, we will just keep pushing that particular opening bracket of whichever type into the stack, right? We will just keep pushing every time we see a opening bracket, right? And whenever we see a closing bracket, we will just pop out of the stack, right? We will just pop the top element from the stack, and we will see if that top element, like the character that has been popped out, whether that is a matching opening bracket of the current closing bracket or not, right? So for example, when I'm over here, right, since this is an opening bracket, I will just push this particular bracket into my stack, right? And I will proceed. Then again, I will push this particular opening bracket into my stack. Again, I will push this particular opening bracket into my stack. And the moment I reach over here, since it is a closing bracket, now I will pop out of the stack, right? And now I will get this particular opening circular bracket, right? Which matches the respective current closing bracket, right? Which is also circular. So that means this is a valid match. And now I will just proceed, right? And then again I will see, again I will get a closing bracket over here. So again I will pop out of my stack and I will match these two brackets, right? If I'm able to match all the brackets after traversing all the elements of this particular string, that means the entire expression is balanced. If I'm not able to do so, it would mean that the expression is not balanced and I will just return false, right? So that's the entire algorithm that we are going to follow. Now maybe let's just try to backtrace this particular algorithm on this input. So over here, if you see, this is my input expression, right? And over here, you will see the stack contents one by one as we are traversing each character of the string, right? So now in the first iteration, I have a opening square brace, right? So I will just push it into my stack, right? Next, I get a curly open brace. Again, I will push it to my stack. Next, I get a circular open brace. Again, I will push it to my stack. And now I will get a closing brace over here, right? And the moment I get a closing brace, I will just pop out from my stack, right? And since they were matching, like the opening brace match the current closing brace, so it will be a valid match, right? And I will proceed, right? Now when I go to the next character, I will get a curly closing brace, right? So again I will pop out from my stack, right? Again there will be a match. Then I will proceed to the next character. Now again it is a closing brace, so again I will just pop out from my stack and again the braces will match, right? And now in the end, once I've traversed all the characters of the input string, I will just see whether my stack is now empty or not, right? If it is empty, it would mean that all the opening braces were able to match with their respective closing braces in the correct order, right? Because if there would have been a mismatch in between, I would have already returned a false over there, right? And since the stack is now non-empty, that means there is no opening braces left to be matched now, right? All the opening braces have been matched. And that's how we can say that this particular input expression is balanced, right? And we will now just return true, right? So that's the entire algorithm. And now talking about the time and the space complexity. See, time complexity, we are just traversing each character of this particular input expression once, right? We are just traversing this particular string once. So that means it will be linear. It will be order of n, right? That will be the time complexity. And now talking about the space complexity, since I'm using an extra stack over here of size n, in the worst case, my space complexity will also be order of n, right? So time complexity and space complexity both will be order of n over here, right? So this is the entire solution. Now let's write the code for it. All right. So now to start with, let me just first of all define this function, and I will name it as isBalanced, right? Like this. And this will accept the input string s, right? And now what I will do is I will just declare and initialize an empty stack, right? And I will use the array implementation of the stack over here, right? And now I will just capture the length of this particular input string in a variable n. And now what I will do is I will just declare a hash map over here, and this particular hash map I will use to basically match a given type of closing brace with its respective equivalent opening brace, right? I will maintain that mapping of the braces, opening and closing braces over here in this particular hash map. And then I will use the reference of this particular hash map in my code, as I'm traversing through the input string, to basically keep matching the closing braces with the respective opening braces, right? So we will see that in a moment. What I will do is, in the keys, I will just give the different types of opening braces possible, and their respective values will be the respective closing braces of the same type, right? So this is for the circular brace. Now similarly, I will do the same for the curly brace as well, like this, right? And similarly for the square brace, like this. Right? So this should be fine. And now what I will do is, and of course this should be curly braces over here. Sorry about that. Like this. And I think there's an extra comma over here. So let me remove that. And now it should be good, right? And now what I will do is, now I will actually traverse each character of the input expression, right? The input string. So what I will do is, I will do for I in range n being the length of the input string, I will see if the current character, that is s of I, is already present in the hash map, right? And what does this mean? If it is present in the hash map, that means it will be a part of the key of the hash map. It will be one of the key of the hash map. And if it is a key of the hash map, that means it will be an opening brace, right? Of some kind, right? We are not concerned about the type over here, but then we are only concerned if it is an opening brace or a closing brace, right? Because it is also given that the input string can only have brackets, right? It cannot have any other character. So that means I will just check whether this particular current character is an opening brace or not with this condition, right? And then if it is, I will just push it blindly into my stack, right? Because it is an opening bracket, like this. And else, if the current character is not an opening bracket, if it is a closing bracket, then what I will check is that if the length of my current stack is actually equal to 0, or the hash value of the top element of the stack, like this, is not equal to the current character that I have, right? So in that case, I will just return false, right? So I hope you got it. We are just checking if the stack is empty, right? So if the stack is empty and if I'm getting a closing bracket, that means this particular closing bracket is unbalanced. There is no matching opening bracket for it because the stack is already empty, right? So that's one condition in which we can return false. Or what we need to do is we have to pop out of the stack, right? The last element. And then we have to see that the character that we got, that will definitely be our opening bracket, but we will just look up that particular opening bracket in this particular hash to get the corresponding closing bracket, right? And that closing bracket should basically match with the current closing bracket that I got at the current character, right? So that's what I'm doing over here. I'm just trying to match, the closing bracket of the current top element of the stack with the current character, if they match or not. If they don't match, in that case also I will return false, right? So that's the negative check that I'm doing over here. In case, both of these conditions are false, in that case I will just continue, right? I won't do anything, right? So that's what I'm doing over here. And then finally, once I've traversed all the characters of this particular input array, and if I never returned a false in between, that means I was able to match all the closing brackets that I got with their respective opening brackets, right? But now just one last case that we need to check is that if there is no extra opening bracket in my stack left, which does not saw a closing bracket, right? A matching closing bracket. So in that case, I will check if the length of my stack is now empty or not, right? After coming out of the for loop. If it is not empty, if it is greater than 0, the length of the stack, then in that case, again, I will just return false, right? Like this, right? And if this is not the case, if my stack is now empty, that would mean that, the entire expression of brackets is actually balanced, and I was able to match every opening bracket with its corresponding closing bracket, right? And so now I will just return true over here. So that's the entire solution. That's the entire code for it. And now maybe we can quickly validate this particular solution. So maybe what I will do is I will just declare a string over here, string of brackets, and I can just do it this way, right? So this is my input expression. Now what I will do is I will just print the output of this particular is balanced function when ran over this particular input string s, right? And now my output should be true over here, right? Because this is balanced. So now if I run this particular code, I get true over here, right? And also let's do another check where I don't have a balanced string, right? So over here, let me just swap the positions of these two. And now if I run this, I should basically get false, right? So this is the correct solution. And now I will see you in the next question. Thank you.